In a distant star system far beyond the blue glow of Earth, there existed a technologically advanced civilization that had long ago mastered interplanetary travel. Their home world was rich with oceans of silver clouds and floating research cities where scientists studied the mysteries of the universe. Among the many celestial bodies they observed, one small, blazing world captured their attention more than any other. It was a tiny planet circling extremely close to a fierce yellow star. The aliens called this world the Furnace Wanderer, but in human astronomy, it is known as Mercury. From afar, the planet looked small and unremarkable, yet every scan revealed extreme conditions that made it one of the most hostile environments any explorer could imagine. One day, the Grand Exploration Council gathered in a massive transparent dome overlooking their home star. The council had decided to launch a daring mission to Mercury. The goal was simple, yet incredibly ambitious. They wanted to collect soil from the surface of this scorched planet and bring it back for study. Scientists believe the rocks and dust of Mercury could reveal secrets about how planets are formed close to stars and how the earliest materials of the solar system evolve over billions of years. A team of elite astronauts, known as the Stellar Survey Crew, was selected for the mission. They were brave explorers trained to land on worlds of ice gas and volcanic fire, but even they had heard stories about Mercury. They knew this planet was different. As the crew gathered in the mission hall, a respected elder scientist entered the chamber. His name was Master Terrell, the most experienced planetary physicist of their civilization. Terrell had spent decades studying Mercury, and the council had asked him to brief the mission crew about the challenges they would face. The room became silent as the wise scientist activated a glowing hologram of the tiny planet. The projection slowly rotated, showing a gray, cratered surface that looked strangely similar to a moon. Terrell began speaking in a calm but serious tone. Explorers, you're about to travel to the most extreme rocky world in this star system. Mercury may appear small, but it is a planet of extraordinary conditions. It orbits closer to the star than any other planet. The average distance between Mercury and the star is about 58 million kilometers, which means the sunlight striking its surface is more than 6 times stronger than what planets like Earth experience. The crew watched the hologram brighten until the planet looked like a glowing ember. Terrell continued explaining that this intense proximity created temperatures that could destroy unprepared explorers instantly. When the sunlit side of Mercury faces the star, the surface temperature can reach around 430 degrees Celsius. That heat is powerful enough to melt metals such as lead. Any spacecraft landing on the planet must endure this furnace-like environment while protecting its crew and equipment. But the scientist raised one long finger to emphasize something even more surprising. Despite this blazing heat, Mercury is also home to some of the coldest natural places in the entire solar system. The crew looked confused. How could the same planet contain both burning heat and deep cold? Terrell explained that Mercury has almost no atmosphere. Unlike Earth, which is wrapped in a thick protective layer of gases, Mercury possesses only a thin trace of atoms drifting above the surface. Because of this, the planet cannot trap heat. During the long night, when the surface turns away from the star, temperatures can drop to minus 180 degrees Celsius. In other words, the planet experiences the greatest temperature swing known among rocky planets. The crew members exchanged glances, realizing they would be landing on a world that shifts from blazing furnace to frozen wasteland. Terrell expanded the hologram to show Mercury's orbit moving rapidly around its star. He explained another strange fact. Mercury completes one full orbit around the star in just 88 Earth days, making its year incredibly short compared with many planets. However, its rotation is slow and unusual. The planet spins 3 times for every 2 trips around the star. Because of this unique motion, the time from one sunrise to the next on Mercury is about 176 Earth days. Imagine standing on the surface and waiting half a year for the sun to rise again. The crew began to understand that the mission would involve more than simply landing and collecting soil. Timing would be crucial. Landing during the wrong phase of the day could expose the explorers to unbearable heat. The wise scientist then shifted the hologram closer, revealing enormous circular scars across the planet's surface. These were impact craters created by ancient collisions with asteroids and comets. Without a thick atmosphere to burn incoming rocks, Mercury had been bombarded for billions of years, leaving its surface heavily cratered like a cosmic battlefield frozen in time. One enormous basin, known as Caloris, stretched across more than 1,500 kilometers. It was formed when a giant asteroid slammed into Mercury long ago, releasing energy greater than millions of nuclear explosions. Around this basin, the ground cracked and folded, creating towering cliffs called scarps, some hundreds of kilometers long. These geological features prove that Mercury had once been a much hotter and more active planet, whose interior slowly cooled and shrank. As the planet contracted, its crust wrinkled, forming cliffs that still stretch across the landscape today. Terrell paused and looked directly at the crew. All of this information, he said, is important because your mission is to gather soil samples from this ancient surface. The dust and rock of Mercury hold clues about the earliest days of planetary formation. Scientists believe the planet contains an unusually large metallic core that makes up most of its interior. Studying Mercury's surface materials could reveal how this dense core formed and why Mercury became so metal-rich compared with other rocky planets. But the scientist's voice grew even more serious as he continued. Despite all our technology, the mission remains extremely dangerous. The radiation from a nearby star, the extreme temperatures, the lack of atmosphere, and the unpredictable terrain make survival difficult. According to our calculations, the probability of a safe return is less than 1%. The words hung heavily in the silent chamber as the explorers realized the gravity of what they were about to attempt. Yet the mission also promised knowledge that could transform their understanding of planetary science forever. The mission hall remained silent after Master Terrell revealed the frightening number. A return chance of 1% was not a statistic that explorers heard often. Yet the crew members did not panic. They were chosen precisely because they understood that exploration sometimes required extraordinary risk. The hologram of Mercury continued to rotate slowly in the air, casting pale reflections across the chamber walls. Terrell looked at the faces of the astronauts and continued his briefing. He explained that before they even attempted to land on Mercury, they would face one of the most difficult challenges in space travel, which was simply reaching the planet. Many young scientists assume that traveling to a planet closer to a star should require less effort than traveling to a distant one. In reality, the opposite can be true. Mercury moves around the star at incredible speed because of the powerful gravitational pull of the nearby star. Its orbital speed is around 47 kilometers per second, which makes it the fastest moving planet in its system. A spacecraft approaching Mercury must slow itself dramatically in order to match this speed, otherwise it will simply fly past the planet and disappear into deep space or fall toward the star. Terrell projected a second hologram showing the curved path of a spacecraft weaving through space like a thread around invisible gravitational currents. To reach Mercury safely, explorers must perform a series of complex gravity assist maneuvers using other planets. These maneuvers allow the spacecraft to gradually lose energy and spiral closer to the star without burning enormous amounts of fuel. The scientists explained that even the most advanced probes ever built had to follow this slow dance through space. One ancient robotic mission required several years of repeated planetary flybys before it could finally settle into orbit around Mercury. For a crewed expedition, the navigation would be even more delicate. The astronauts watched carefully as Terrell demonstrated how the ship would approach the planet from the darker side where temperatures were lower. The landing zone would need to be selected carefully because Mercury's surface is far from smooth. Unlike Earth, which is oceans, plains, forests, and mountains, Mercury is dominated by ancient impact craters that formed billions of years ago. Many of these craters overlap each other, creating rugged terrain filled with sharp ridges and steep walls. The wise scientist magnified a region near the equator where thousands of circular depressions formed a chaotic pattern. Each crater represented the violent collision of a cosmic rock striking the planet at enormous speed. Without an atmosphere to slow them down, asteroids strike Mercury, directly producing explosions that can scatter debris across hundreds of kilometers. For the mission crew, this meant landing sites had to be chosen with extreme caution. Even a small mistake could send the spacecraft into a jagged crater wall. But the dangers did not end there. Terrell expanded the hologram further until enormous cliff-like structures appeared stretching across the planet's surface. These were the planetary scarps he had mentioned earlier. When Mercury's interior cooled over billions of years, the planet shrank slightly, causing the crust to compress and wrinkle. The result was massive ridges that could rise several kilometers high and extend for hundreds of kilometers. Some scientists believe these scarps were still slowly forming even today, which suggested Mercury's interior was not completely inactive. The mission crew would need to avoid these unstable regions where the ground might shift or collapse. Terrell then shifted the display to another surprising feature of Mercury. Despite the planet's closeness to the star, there existed places that sunlight had never touched for billions of years. Near the poles, deep craters were tilted in such a way that their floors remained permanently shadowed. Because Mercury's axis tilts only slightly, the sun never rises high enough above the horizon to illuminate these crater bottoms. In those eternal shadows, temperatures remain extremely low, allowing water ice to survive. The crew members leaned forward in curiosity. Ice on the hottest planet seemed impossible, yet multiple observations had confirmed its existence. Radar scans and spacecraft measurements revealed bright reflective patches inside these polar craters, which scientists interpreted as deposits of frozen water mixed with dark organic material delivered by comets long ago. Terrell explained that while their primary mission was to collect soil from sunlit regions, the polar ice deposits represented another valuable scientific target. Studying this ice could help researchers understand how water is transported across a solar system and how volatile compounds survive even in hostile environments. However, reaching those polar craters would introduce new challenges. The areas were extremely cold and completely dark, which meant explorers would rely entirely on artificial lighting and thermal systems to survive. The temperature difference between sunlit ground and shadowed crater floors could exceed 600 degrees Celsius, making equipment design extremely complicated. The scientists then focused on Mercury's internal structure. Beneath its cratered crust lies one of the most unusual planetary interiors known to science. Mercury possesses a massive iron core that makes up roughly 85% of the planet's radius. Compared with other rocky planets, this core is enormous relative to the planet's overall size. Scientists believe that early in the solar system's history, Mercury may have been struck by a giant object that stripped away much of its outer rock, leaving behind the dense metallic interior. Another possibility is that intense solar heat during formation prevented lighter materials from accumulating close to the star. Whatever the true explanation, the result is a planet that is incredibly rich in metal. This metallic interior also generates something rare for such a small world, a magnetic field. Although weaker than Earth's magnetic field, Mercury still possesses a global magnetic environment created by the motion of molten metal inside its core. This magnetic field interacts with the powerful solar wind streaming from the nearby star, creating a constantly shifting magnetosphere around the planet. For the mission crew, this meant their spacecraft would experience bursts of charged particles and magnetic disturbances that could disrupt electronics and communication systems. Protective shielding and careful navigation would be essential during both orbit and landing operations. As the briefing continued, Terrell reminded the crew that Mercury's low gravity would also influence their movements on the surface. The planet's gravity is only about 38% of Earth's gravity, which means astronauts would feel much lighter. Walking would require careful balance because each step could carry them farther than expected across the dusty ground. At the same time, the lack of atmosphere means there is no air resistance, so dust kicked up by landing thrusters could travel long distances and remain suspended in slow, graceful arcs before settling again. All these factors combined to create a world that was both fascinating and unforgiving. The crew understood that their mission would provide priceless scientific information about planetary formation, but would also test every aspect of their training technology and courage. As Terrell dimmed the hologram, he spoke one final sentence before ending the second phase of the briefing. Mercury is not simply another planet to explore, he said. It is a place where the extremes of physics reveal themselves openly, and only the most prepared explorers will survive long enough to uncover its secrets. The lights inside the mission chamber dimmed slightly as Master Terrell activated another layer of the holographic projection. The rotating image of Mercury slowly expanded until it filled the entire room, allowing the explorers to see every crater, ridge, and scar in astonishing detail. The wise scientist walked slowly around the projection while the crew watched silently. He began explaining that Mercury is not only extreme because of its heat and cold, but also because of how ancient and untouched its surface is. On many planets, wind, rain, flowing water, and tectonic activity constantly reshape the landscape. Mountains erode, valleys form, and old craters slowly disappear. Mercury, however, lacks the atmosphere and active geology needed to erase its past. The result is a planetary surface that acts like a frozen archive of cosmic history. Every crater visible on Mercury tells a story about a collision that happened billions of years ago during the violent early era of the solar system. The explorers studied the countless circular marks covering the world. Some craters were small, while others stretched across hundreds of kilometers. Terrell explained that scientists classify these craters based on their shape and structure. Younger craters appear sharp and bright with rays of debris, spreading outward like spokes from a wheel. Older craters look smoother and more eroded because tiny micrometeorites constantly bombard the surface, grinding rocks in a fine dust. Over immense periods of time, this process creates a loose layer of soil known as regolith. This regolith is exactly what the mission crew has been sent to collect. It contains fragments of ancient rock mixed with microscopic glass particles created during high-energy impacts. Studying this soil back in their laboratories could reveal the chemical composition of Mercury's crust and provide clues about how planets formed close to stars. Terrell zoomed the projection toward a gigantic circular structure dominating one hemisphere of Mercury. The crew recognized it immediately because it looked like a massive scar carved into the planet. This was the enormous Calorus Impact Basin, one of the largest collision features known on any rocky world. When the asteroid that created this basin struck Mercury billions of years ago, the energy released was unimaginable. The explosion melted huge portions of the crust and sent shock waves through the entire planet. On the opposite side of Mercury, the surface was shattered and uplifted, forming chaotic terrain filled with strange hills and ridges. The existence of such features shows how violent the early solar system truly was. For the mission team, Calorus Basin represents both a danger and an opportunity. Its interior contains unique geological formations created by ancient volcanic flows that occurred after the impact. In certain regions, molten rock once flooded the basin floor, forming smooth plains darker than the surrounding highlands. These volcanic plains indicate that Mercury was once geologically active long ago, when its interior still contained significant heat. By collecting soil samples from both cratered highlands and volcanic plains, the explorers could compare materials from different stages of Mercury's history. The scientists then shifted the hologram again, revealing another unusual characteristic of Mercury. Across the planet, long curved cliffs stretched like wrinkles across the crust. These structures, known as lobate scarps, are evidence that Mercury has been slowly shrinking over billions of years. As the planet's enormous metal core cooled It contracted, slightly causing the outer crust to compress. When the crust could no longer stretch, it cracked and folded, creating these massive cliffs. Some scarps are several kilometers tall and hundreds of kilometers long, making them among the largest geological structures on the planet. Terrell warned the crew that landing near these cliffs would be extremely dangerous because the slopes are steep and unstable. The spacecraft must descend onto relatively flat terrain where the regolith is deep enough to collect but stable enough to support the landing gear. After discussing the surface, the scientists turned the crew's attention upward toward the invisible environment surrounding Mercury. Many people assume that a planet without a proper atmosphere exists in empty space, but Mercury actually possesses a very thin outer envelope called an exosphere. Instead of thick layers of gas like Earth, Mercury's exosphere is made of individual atoms blasted from the surface by solar radiation and tiny meteorite impacts. These atoms include sodium, oxygen, hydrogen, helium, and potassium. Because gravity is weak and temperatures fluctuate dramatically, these particles constantly escape into space, while new atoms are released from the surface. This creates a delicate and ever-changing cloud around the planet. For scientists, the composition of the exosphere provides important clues about the minerals present in Mercury's crust. During the mission, specialized instruments would measure these particles while the crew works on the surface, allowing researchers to connect atmospheric data with physical soil samples. Terrell also explained that Mercury's proximity to its star exposes it to intense solar radiation and powerful streams of charged particles known as the solar wind. Normally, a thick atmosphere would shield a planet from these particles, but Mercury's surface is directly exposed. However, the planet's magnetic field offers partial protection by deflecting some of the incoming solar wind. This magnetic field, though much weaker than Earth's, still forms a small magnetosphere around the planet. Inside this magnetosphere, charged particles become trapped and accelerated, producing sudden bursts of energy that occasionally slam into the surface. When these particles strike the ground, they can knock atoms loose from rocks, adding material to the thin exosphere. The mission crew would need to monitor these events carefully because intense solar activity could temporarily increase radiation levels around the landing site. As the briefing continued, the hologram shifted to show the sun rising slowly above Mercury's horizon. Terrell described how strange the sky would appear to the explorers standing on the surface. Because Mercury rotates slowly and orbits the star rapidly, the motion of the sun across the sky behaves in unusual ways. In certain locations, the sun may appear to rise, then pause, and even move backward before continuing its path across the sky. This strange effect happens because Mercury's orbital motion briefly outpaces its rotation. To someone standing on the ground, the sun would look enormous, more than twice the size it appears from Earth, and its light would be dazzlingly bright. Shadows would be sharp and black because there is no atmosphere to scatter sunlight. The sky itself would remain completely dark even during daytime, revealing distant stars shining faintly near the brilliant sun. The crew members imagined what it would feel like to stand in such a place. Beneath their boots would lie ancient dust untouched for billions of years, while above them the giant star blazed in a silent black sky. It would be both beautiful and terrifying. Finally, Master Terrell addressed the ultimate purpose of the mission. By bringing back just a few kilograms of Mercury, soil scientists could perform detailed laboratory experiments impossible to conduct remotely. They could analyze isotopes, determine mineral compositions, and study how intense solar radiation alters planetary materials. These discoveries might reveal how rocky planets survive close to their stars and why Mercury evolved so differently from worlds like Earth or Mars. Yet despite the scientific promise, the mission remained incredibly dangerous. The harsh environment, mechanical stress, and radiation hazards meant that the explorers must work quickly and efficiently. Every minute on the surface would push both the crew and their technology to the limit. The wise scientist looked at the astronauts once again and reminded them that knowledge has always required courage. Mercury may be small, but its secrets are immense, and only those willing to face its extremes will ever uncover them. The final phase of the briefing arrived, and the chamber grew quiet again. Master Terrell slowly dimmed the giant hologram of Mercury until the blazing planet became a small, glowing sphere floating above the center of the room. The wise scientist looked at the explorers for a long moment before continuing. His voice was calm, but carried the weight of decades of research and observation. He explained that despite all the dangers they had discussed, the mission to Mercury was one of the most important scientific expeditions their civilization had ever attempted. For generations, their astronomers had studied the small planet from afar. Powerful telescopes and robotic probes had collected images, measurements, and data, but none of those instruments could replace direct exploration and physical samples. Real understanding often begins when scientists hold a piece of another world in their hands. The soil of Mercury was not just dust and rock. It was a record of the earliest days of a solar system that formed more than 4.5 billion years ago. When planets were young, enormous collisions were common. Asteroids and protoplanets slammed into each other, shaping the structure of entire worlds. Mercury survived those violent times, but the scars of that era still covered its surface. By studying the minerals and isotopes within Mercury's soil, scientists hoped to reconstruct the timeline of those ancient events. Such knowledge would help them understand not only Mercury, but also the formation of other rocky planets throughout the galaxy. The crew listened carefully as Terrell described the final plan of the expedition. Their spacecraft, named Horizon Seeker, would travel for many months through deep space, gradually adjusting its path through precise gravitational maneuvers until it reached Mercury's orbit. Once there, the ship would enter a stable elliptical orbit around the planet, allowing the crew to map the surface in detail before landing. Advanced scanners would identify a safe location within an ancient plain near the edge of a cratered region. This landing site was chosen because it contained both impact, debris, and volcanic material, providing a mixture of geological samples. The descent would occur during a period when the sun sat low on the horizon, reducing surface temperatures and giving the astronauts several hours of manageable working conditions. When the moment arrived, the landing module would detach from the main spacecraft and slowly descend through the black sky toward Mercury's silent landscape. Unlike Earth, there would be no clouds, no wind, and no sound. The engines would fire briefly, kicking up clouds of gray dust that arced through the low gravity before settling again across the ground. The first alien explorer to step onto Mercury would leave footprints in soil that had not been disturbed for billions of years. Terrell described the procedures the crew would follow. They would deploy automated drills and collection arms designed to gather samples from several depths beneath the surface. Some samples would come from loose regolith, while others would be extracted from solid rock fragments created during ancient impacts. Special containers would seal the material to protect it from contamination during the return journey. At the same time, portable instruments would analyze the soil directly on site, measuring chemical composition, radiation, exposure, and mineral structure. Cameras and scanners would record every detail of the surrounding terrain, creating high-resolution maps for future missions. The crew would also release small robotic probes that would travel short distances across the surface, exploring nearby craters and geological formations. Each probe would transmit additional measurements about temperature variations, magnetic activity, and the thin exosphere drifting above the planet. Every minute of operation would generate valuable scientific information. Yet the explorers knew that time would be limited. Mercury's environment does not allow long, comfortable expeditions. As the sun gradually climbed higher above the horizon, temperatures would begin to rise rapidly. The landing module's cooling systems could withstand extreme heat for a short period, but eventually the environment would become too dangerous. After completing their sample collection, the crew would return to the module and launch back into orbit where the main spacecraft waited. The ascent would be swift because Mercury's gravity is weaker than that of many planets, allowing the module to escape the surface with relatively little fuel. Once reunited with the Horizon Seeker, the explorers would begin the long journey back toward their home world, carrying with them a small but priceless cargo of Mercury soil. Terrell paused for a moment before revealing the final projection. It showed the possible outcomes of the mission calculated by their best scientific models. The harsh conditions and narrow margins for error meant that survival was uncertain. A sudden solar storm could overwhelm the spacecraft's shielding. A navigation error during descent could send the landing module crashing into a crater wall. Mechanical failure caused by intense heat could trap the crew on the surface. These are the reasons the probability of a safe return had been estimated at only 1%. But the scientists then showed another image. It displayed the potential discoveries awaiting them if the mission succeeded. Scientists could analyze Mercury's metal-rich minerals to learn how its enormous iron core formed. They could study microscopic glass created by ancient impacts to understand the chemistry of early planetary crusts. Isotopic measurements could reveal how material near a star evolves under intense radiation. Even tiny traces of volatile elements trapped within the soil might explain how water and organic compounds travel across space on comets and asteroids. Such discoveries would transform planetary science forever. The explorers looked at each other, realizing that the knowledge gained from this mission could influence generations of researchers. The briefing finally ended, and the crew departed to prepare for launch. Months later, the Horizon Seeker began its journey across the silent darkness of space. The long voyage tested their patience and skill, but eventually the blazing world of Mercury grew larger in their viewports. The spacecraft entered orbit exactly as planned, and the crew successfully mapped the landing site. When the descent module separated and drifted toward the surface, every system performed with remarkable precision. The landing was rough but successful, and the explorers stepped onto the smallest planet in their system. For several intense hours, they worked quickly, collecting soil samples, deploying instruments, and recording the alien landscape around them. The sun loomed huge above the horizon, casting long shadows across ancient craters. Temperatures slowly climbed, but the mission continued exactly according to plan. When the time came, the explorers returned to their module and launched back toward orbit, carrying sealed containers filled with Mercury's dust and rock. Against all expectations, the spacecraft completed its return journey safely. The crew arrived home exhausted but triumphant. Scientists immediately began analyzing the precious samples, and the results were extraordinary. The soil confirmed that Mercury's crust contained unusually high concentrations of metals and sulfur, unlike most other rocky planets. Tiny mineral grains revealed evidence of intense solar radiation altering their chemistry over billions of years. Some samples contained microscopic glass droplets formed during massive impacts in the early solar system. Others showed traces of volatile elements, proving that even a planet so close to a star could retain certain delicate materials under the right conditions. These discoveries helped scientists refine their models of planetary formation and provided new insights into how worlds evolve near their stars. The mission that once seemed almost impossible had succeeded, and the knowledge gained from a handful of Mercury soil reshaped their understanding of the universe. Master Terrell later addressed a gathering of young students and researchers. He reminded them that exploration is rarely easy and that the most valuable discoveries often lie in the most dangerous places. Mercury remained a harsh, unforgiving world, but it had shared its secrets with those brave enough to reach it. The story of the Horizon Seeker mission became a legend among explorers and scientists, alike proving that even a tiny planet blazing beside a star can change how an entire civilization understands the cosmos.